In this class, we are going to talk about the introduction to AWS or Amazon Web Services. Whenever you have to go and talk about AWS or Amazon Web Services, is that Amazon Web Services or AWS offers a broad set of global cloud-based products, including compute, storage, databases, analytics, network, mobile, developer tool, management tools, IoT, security, and enterprise applications. These are available as on-demand, which is available at the second level, means if you are using the product for 1 day, you'll be charged only for 1 day, and with pay as you go pricing. So you only pay for the resources that you are using. AWS can be used from data warehousing to deployment tools, from directories to content delivery. And over 175 services of AWS are available as of now. Thus, if you have to create a new service, it can be provisioned very quickly without any upfront capital expense. Thus, this allows the enterprises, the startups, the small and medium-sized businesses, and customers in the public sector to access the building block they need to respond quickly to any changing business requirement. AWS started in 2006 when it began offering the IT infrastructure services to businesses as web service, which now is known as cloud computing. One of the key benefits of cloud computing is that it gives you the opportunity to replace your upfront capital infrastructure with low variable cost that will scale up with your business. With the cloud business, you no longer need to plan for and procure the servers and other IT infrastructure weeks or months in advance. Instead, you can start using them and create the servers in minutes and deliver the results faster. Today, AWS provides a highly reliable, scalable, low-cost infrastructure platform in the cloud that is powering thousands of businesses in 190 countries around the world. In this session, we are going to go and talk about AWS, and we'll look into few of the services of AWS on the fly. This will give us a basic understanding of how AWS actually works and how do we get started with Amazon Web Services. The first thing to note on AWS is on the top left, you see the services. These are the various services which AWS offers you. There are services inside the compute section, the storage section, database section, migration and transfer section, networking and content delivery, management and governance, security, identity and compliance, and application integration. There are many more services provided by AWS, but for the preview of this course, for the intro of AWS, we are going to primarily deal with few of the services under the head that we just talked about. Whenever you open AWS, the first service that you will always see will be EC2. EC2 stands for Elastic Compute Cloud. And you will see that you see EC2 console or Elastic Compute Cloud console on the first section. Elastic Compute Cloud can be used to create the servers. The servers can be your Windows server or your Unix server, and you are free to install or use the Unix server within the provided guidelines for your services that you require in EC2. So let's get a brief about what EC2 is, what are the volumes, security groups, load balancer, auto scaling, and so on. So over here inside the instance type, you have the various types of servers which AWS has to offer you. These starts from the T2 server or the auto scaling servers, or as we call them, the burstable instances. These instances can scale up automatically, which is also known as vertical scaling, if in case required. Then you have the non-burstable instances, which starts with the A instance, which has the ARM processors, followed by the C instances, which has better compute power. Then going to the next page, we see the G instances, which has better graphical memories. Then we have the M processors, which are the general purpose instances. And then we have the R instances, which has more RAM. So depending on the type or your requirement, how you want to work on AWS, you can choose a server of your choice. After this, we have instances where you can go and create your instances or your server at runtime. We will come back to this after we are done with other services of EC2. For instances, the volume you can consider as the volume of your server or of your computer itself. If in case you need some storage inside AWS where your servers can attach to, for that you can go and create a volume. To create a volume, you just have to go click on create volume and select the various volume types that you have inside EBS. GP3 is the newest of them, which has both Ieps and throughput. Then you have your GP2, the older version. If in case you have the requirement of having specific number of Ieps or input output per second, in that case you can go for either IO1 or IO2. In scenario where you might need specific throughput, you can go for cold HDD or a throughput optimized HDD, or you can straight away go for the GP3 in this case, which was launched in December 2020. In this case, you have the option both to select your Ieps and throughput. Also remember that you have the AZ or the availability zone where you want to place your volume in. Now, if your server is inside AZ1A and your volume is inside 1B, this actually won't make any sense because the servers and the volumes have to be physically located inside the same data center. In this case, if your server is in 1A, your volume necessarily has to be in 1A. Now that we are done with the volume, let's create one over here, create volume, and I'm just going to name it as V1. This. Now, if you have a volume and you want to take a backup of that volume, you can take help of a snapshot. A snapshot is incremental in nature, and it will have the backup of your volume. Whatever data is inside the volume will land up inside your snapshot. The difference between a volume and a snapshot is only the backup. Also, the volume is inside a AZ or availability zone, whereas a snapshot is inside the region itself. It doesn't have any concept of availability zone. So let's test it out. For that, you can select the volume that we created, click on actions, click on create a snapshot. You can give a name to this and click on create snapshot. So once it is done, it will be available inside your snapshot over here. So if your volume size was 100 GB, the snapshot size will also be 100 GB. Now from this snapshot, if you want, you can go and create a new volume from this. For doing that, click on actions, click on create volume, select the AZ where you want your volume to be created at, and just click on create volume. And now you will see that you actually have two volumes because one is the original volume and second is the backup that we created some time back. So that's the concept of our EBS or elastic block store. For our purpose, we will delete the volume and we will see that my snapshot still remains. So deleting the volume or deleting the snapshot does not have any effect on each other. So in ideal scenarios, what happens is even if you go and delete the volume, your snapshot still remains. Let's go to the security groups now. Security group can be used in scenarios. Consider a snapshot security group like your firewall, basically, which will allow whatever traffic has to flow into your network interface or your server or your database. You can call it by whatever name you understand it better. But essentially, it is the set of the ports which are allowed into that server via the inbound and the outbound. And also it also tells you what all IPs are allowed in and out of that particular server. So you can go and create a security group. Just click on create security group over here and you can do that. that can be done. Then apart from that, you have your elastic IPs over here. Elastic IPs are the static IPs which are allocated by AWS to you only. So if in case you need a specific IP address, you can go for the elastic IP, and this IP can be added to your particular instance. So if in case you need to get a static IP address for any website, in that case, you can take help of the elastic IP. And if you allocate a elastic IP for yourself, in this case, this IP can be used with any of the servers that you have created. For instance, my elastic IP over here is 65.2.49.77, which means that this particular IP address is for my use alone in this world. So if in case you want, you can use this elastic IP also. Next we have is the key pair. A key pair can be used to log in into a server. Consider this like your password. Whenever you need to log in into a computer, you need the password. So in this case, you can take help of a key pair. So using a key pair, you can either make a connection with the Windows server or with the Unix server at any point of time. So if you want, you can go and create your own key pair. So if in case I need to create a key pair to log in into any of the instance, I can go for create key pair over here, give it a name. So let's say I'm naming it 04 July 2021, and I click on create key pair. So this key pair will be created for me, and it will be stored inside my local device. Remember that if in case you happen to lose your key pair, there is no way AWS or the cloud is going to give the key pair back, and you will lose access to that very instance. Though there are ways by which you can go and get the access back to the cloud again, but directly there's no way for doing that. So I have a key pair over here. Now let's go and start to create a server or a web server. You might have heard about Apache web servers, or the web servers wherein you can go and create any instance. So in this case, you can just go and click on instance over here, and then basically if we do this, we will click on launch instance, and then I have the options of selecting multiple operating systems over here. So our operating system is the base software that runs your computer. Basically it's like the interface between you and the hardware of your computer. So we have multiple options over here. I have a Windows server, I have a Ubuntu 20 server, I can have SUSE, I can have Red Hat Enterprise Linux, Amazon 2, Microsoft servers, and so on. So for the sake of this class, we'll be taking in two servers primarily. One will be a Unix server, and the second will be a Windows server. So if in case I have to go with a Unix server, I'll go for the Ubuntu server 20 over here. I'll just select the instance. So I selected a x86 instance, as we talked about earlier, where we said that the instance or the processor type can be x86 or ARM processor. So in this case, I'll go down, I'll take a T3A small instance, which means it has 2 CPUs and 2 GB of RAM. So if I take that and I just go ahead and launch my server over here, so I will have the option of selecting the key pairs now. So a key pair, we had already created it in the previous part. So if I select that and I click on launch instances over here, I'll see that this particular server has been created for me. So let's call this server as a web server. Now, right now, just understand that this web server isn't doing anything. It's just a standalone machine. It's like going to the shop and buying a computer, and that computer doesn't have anything installed in front of you. Now, what you will have to do is you will have to go and install a few softwares inside this particular machine. Another point to notice that because this is a Unix based machine, so you cannot directly go and use the UI for that. You will have to do this using the command prompt. Command prompt is like the run command prompt that you have inside your computer. So to make a connection with that particular instance, I can just choose to click on the connect button here, and I see three options: a standalone SSH client, a session manager, and a Ec2 Instance Connect. Instance Connect is the easiest way to connect to your web servers on the cloud using AWS. So we'll choose that and we'll click on the connect button. Essentially what is happening now is that I am able to connect to my machine from the console itself. So if you see over here, the IP is 172.31.16.107, and that is also the private IP, which is the IP of my server, 172.31.16.107. So that's what we are going to do, and let's make a connection with that. For that, I'll just go and type sudo apt-get and update. That is just to update the distribution packages for my web server. And next, what I'll do is I'll go and install a web server inside it. So the web server that I'll use in this case will be Apache. However, you are free to choose any of the web server. It can be Apache web server, it can be your own web server, and so on. So for that, let's go and install that. For that, I'll go and type sudo apt-get install and Apache 2. If I do this, basically the web server will be created for me, and I can actually see something coming up. So let's try that out. Let it run. Anyhow, if I try to open the public IP, in this case over here, it will actually show me the website or the server details, whatever there are. Just one thing to remember before that is that because this is a server, in this case, I will also have to enable the port number 80 or the HTTP traffic for my server. For that, I'll have to go to my security group. I'll have to go to the inbound rules, edit, and I will have to add the traffic for port number 80, which is my web server. If I do anywhere and I click on save rules in this case, now if I go and refresh this page where I had ran my server, I will see that it is indeed working on my Apache web server. So the Apache 2 Ubuntu default page is created for me. Next step is, now that I have my server up and running, if I want to take a backup of my server in general, I will go to actions, I will go to image and create image, and I can give this image a name. So let's call it as backup-web-server. And let's call the description as backup of web server. And now if I click on create image, at this point of time, I will see that an image or an AMI has been created for my instance. Now, our AMI is simply put the backup of your instance. So let's go to our images and AMIs over here, and I see that this is indeed coming up. Now, before we proceed ahead inside our EC2, let's go for the next service of AWS, which is IAM, one of the most important services in AWS, because whenever you are talking about the security, the console, the user management, the policies, whatever you want to create inside your organization, the service that will help you at any point of time is your IAM service, or identity and access management. So first thing first, we'll have to go and create a user in this case. If I click on user groups over here and I click on create a user or a group, I can go and create a user. So let's go and test it out. First of all, I click on users over here. It will navigate to the page where I will go and create add user, and let's call this user as a CLI-user, because this will be used by the command line interface or the CLI. So I have just named it as CLI-user. I have given it the programmatic access, which means I can use this particular user for my programmatic access or via access for my APIs or CLIs or SDKs, which is the software development kit. CLI stands for the command line interface and so on. So if I click on next permissions, I can go and attach any policy to it. A policy essentially put is the rules which you want to give to this particular user. So let's say a user is working in AWS and you want them to give, they should be having access to the storage part and the compute part. So in this case, you'll be giving them access to S3 and EC2. Now, if the user happens to work on the database, you'll be giving them access to RDS. If this user has to manage other users, in this case, you might want to give them access to your IAM. Similarly, if you want to go and give access to the billing, you might want to make them the billing admins or the billing administrator and so on. So in my case, I have selected the group which already has the EC2 full access over here. I click on tags and then review and create the user. At this point of time, I'll be presented with the access key ID and the secret access key. Just like your key pair that we created some time back, this access key ID and the secret access key is only available to you once. So this access key ID and the secret access key can be used with my instance over here. So let's go and create a connection with that instance again. For that, I will choose the connect button here and I'll see that the connectivity has been done with my server. Before we get started with AWS CLI, we'll also have to install CLI. The easiest way is to just type AWS, where the command prompt itself is going to tell me that if in case you need to work on CLI, you will have to go and install this particular service. So it told me that I have to go and do sudo space apt-get space AWS CLI. And that's exactly what we did. And because of that, we have installed CLI inside my server. Now, once this is done, this is how you basically install CLI inside your server. If you are working on a Windows-based instance, you can go and download the installer for Windows-based instance. If you're working on a Unix-based instance, you can install that. So basically the commands are present. You can use them to install any of the installers. Now, just to test out that whether it is there or not, if I go and type AWS, it is telling me that yes, indeed, AWS has been installed. And if you want to run something, you can go and run this command. So we are going to take cue from the previous class that we did, and we will go and create a bucket, and we'll also go and view the buckets that we had created earlier. For that, I can just go and type AWS configure to configure my user at this point of time. It will ask me for the access key ID, which I already have from here. So I'll choose the access key ID. Then the secret access key, which is from here. My region is AP-South-1, and my format is, let's say, table. Now, if everything is good, I should be having access to my instances or to my AWS and so on. So if in case I want to have a look at it, I can just go and type AWS and S3 and LS, which eventually is going to tell me all the buckets that I have. Now let's have a look at the first error, which it told me. It says that access denied while calling the list bucket operation, access denied. The reason for that is this particular user does not have access to S3 permissions or the S3 policy. So what I'll do is I'll go to this user, I see permission, it only has access to EC2 Lambda and Lambda. So what I'll do is I'll click on add permissions, attach the policies, and I will go and give it access to S3. Doing this and clicking on add permission should now be good for me. If I go and run that command again, it should basically now list all the buckets for me. Just it again errored out. The reason is that whenever you update anything inside IAM, it is not reflected immediately at that point of time. It might take some time in reflecting across the data centers of AWS. So a general thumb rule is waiting for a minute or so, and then it should point you and it should be updated. To confirm that, let's go and run the command again, AWS S3LS, and I indeed see all the buckets for me, whatever I have done till now being created. So over here, all the buckets are visible to me. And basically that essentially means that the CLI is working. But let's go and test it out in one another way. So for that, what I'll do is I'll go to S3 first of all, and I'll see the total number of buckets that I have inside this particular S3 console. So right now I have 78 buckets, and let's go by the creation date. The latest option that I have is the bucket that I had for Live bucket over here. So in this case, the latest bucket is this. So let's go and create a bucket over here. So let's say if I want to go and create a bucket, I can just go and type AWS S3 MB S3 colon / and let's give it a name. So let's call the bucket as 04 July 2021. And if that bucket is available, I'll see that it gives me something as make bucket, which also means that if in case the buckets are 78, if you refresh it, now the buckets should become 79. And if I do a sorting on the created date, the latest bucket that I should be having should be 04 July 2021. Now the CLI command can also be used to copy the data from one bucket to the next bucket. Let's test it out. For that, right now, if I go to my bucket, I actually don't see any items inside the bucket. So let's go back and connect my two buckets. Basically, it means that whatever data I have inside bucket one, I'll be transferring it to bucket two. For that, I can go and type AWS S3 sync S3 colon / the bucket name one, which is .live with the next bucket S3 colon / and the next bucket that I created for 04 July 2021. If I do this now, the entire data that was there inside my previous bucket, Live, should go to 04 July 2021. To confirm that, let's go back and refresh this. And I do see that all the items are back inside my particular bucket. To confirm it once, let's go and have a look at any of the object. So if I open this now, I should see my bucket actually, and I actually see the web page in this case. So that's how we can use CLI and we can use IAM for going and managing our resources. Let's go back to IAM. Now that the work of the IAM is done, in ideal scenarios, you should never go and expose your access key ID and the secret access key to any external user. If in case you want, you can just send it via some secured medium to them. And once the job is done, you should ideally go and delete the user. So that completes our IAM part inside AWS or Amazon Web Services. Let's move to the next one. So right now I have my instance, which I have created, which is my web server. If I want to take a backup of it, I already know that I can go to AMIs and create a backup. And if I have created a backup, I can use that backup and I can see that inside my AMIs over here. Using this backup, I can go and create my new web server or my new server, because step one, choosing the AMI, I have already done earlier. Alternatively, if you go to instances and click on instances and click on launch instance, on the left, you are going to see my AMI. This is the AMI that we created some time back, which can be used to create our instance. Going back, if I go to my images and I have my server over here, I can go and create one more server like this. So to create the server, what I'll do is I'll go and use my image or AMI itself. So from AMI, I click on launch, I click on review and launch, and I just go and launch that instance over there. So if this instance is there, what we'll do now is we will go and create a load balancer. We will be securing that load balancer via my ACM or Amazon Certificate Manager. This ACM is going to point to my Route 53, and my Route 53 is going to point to my IP address. So this complete series of steps is what we are going to do. So first of all, let's go and call this as web server -2. Now, next thing that I'll do is I'll go to my load balancers and create a load balancer for me. A load balancer is used in the cases where you have your multiple servers, and to manage your multiple server, you need one machine. So The request goes to your load balancer. The load balancer decides that it should be going to which of the server. And once it forwards the request and gets the response back from that particular server, it will forward it to the client again. So another way to say it, a client sends the request to load balancer. Load balancer has two instances, instance 1 and instance 2. It will be forwarding the message to either instance 1 or instance 2, get the response back, and this response will be sent back to the client. So this is how ideally a load balancer works. So to work on that, let's go click on a load balancer, and we can use any of the load balancers. Now, because this is a website or a web server, I'll choose an application load balancer. So if I click on create over here and give it a name, let's call this as web server hyphen ALB or application load balancer. This is going to work on port number 80, and this will be working inside my this one. Now, if you want, you can also go and give it HTTPS. So that's fine. And I'm selecting my AZs as availability zone 1A, 1B, 1C. Next step, you can choose a certificate from ACM. Now, because I have already created the certificate from ACM in the previous scenario, so I can just choose this option. Click on next certificate. So I have chosen my security group, which will allow traffic from port number 80 and 443. Next is to select a target group. I can either choose it from any of the target groups that I have, or I can create one right now. So let's call this target group as 04 July-2021. And if I click on next register targets, I'll have option to select the instances. Then I create review, create, and my application load balancer should be created now. Now, this might take some time in coming up. In the meantime, let's go back to our instance. We had created web server 1, web server 2. So in ideal scenarios, this public IP should be available for me, and it is. This public IP, however, might not be available for me. And the reason for that is this is not allowing traffic on port number 80. So we'll have to go back to the security groups over here and enable port number 80 also. So edit inbound rule, add rule, just go and make it port number 80, source from anywhere, and click on save rules. So now if this is done, if you go back to your server over here, this one, you should see the web server coming up, provided the service was up and running after we created that. So this is working on 30.235.248.234. This is working on 65.112.203. So I have two servers which are working in parallel. Now, the next thing to do is to create a load balancer that we have already done. And we will just have to wait for this load balancer to actually come up. After it actually comes up, we will see that it is forwarding the traffic either to server 1 or to server 2. So let's just wait for that. Now that it says provisioning over here and this says active, if you see, if I refresh the page, I am pointing to my application load balancer, and load balancer is actually forwarding the traffic either to server 1 or to server 2. Now, our job was not just to do this much, rather what we wanted to do was to go and also create it via Route 53. So what we'll do now is we go search for Route 53, and we will be forwarding our data. So earlier what we had done was, if we had opened our website over here, in this case, this website was forwarding to a CloudFront distribution, which is not present now. So what I'll do is, inside my DNS management, inside the hosted zone, I will be having the forwarding address. I'll just forward it to my actual load balancer. So let's have a look at that. You see, this website was actually earlier being forwarded to your CloudFront distribution, and this CloudFront distribution doesn't exist as of now because we deleted it. So what we'll do now is, we first of all delete this particular record, then we click on create record, then the alias name, and over here we'll go and select the load balancer. So application or the classic load balancer, my region happens to be AWS in Mumbai. So I'll select Mumbai data center, and my load balancer, it is automatically telling me that this is the load balancer. Now, if I want, I can go and create this as it is. So if I click on create records at this point of time, I'll see that now if anyone tries to open my website, which earlier was not opening up, it should come up shortly. Just remember that this might take some time. Though if you have done in Route 53, it actually doesn't take that much time, but still to be on the safe side, just remember it might take approximately 10 minutes. So if I see my website over here, it says ankitsaxena.live and it is forwarding and it says it is not secure. The reason is this website was working on your HTTP. If you want, you can also forward it to your HTTPS page on your instances. Now, going back to my load balancer, I had the listeners. So 80 was being forwarded to this over 443. If you see over here, it says that the security group does not allow. Now, that's the advantage that AWS gives you. If you just are following this, you will realize that this security group is not allowing the traffic on port number 443, which is also the HTTPS port number. So what I'll do is I just have to go to inbound rules over here, click on edit inbound rules, and just go and add the settings for HTTPS. If you click here anywhere, save rules. Now, basically, if you go to your domain, let's test it out. This anyhow was opening always. This, if I try it on HTTPS, I'll see that my website, this one is not secured because it doesn't have certificates. However, this website is secured via the certificate, and it says that the certificate is verified by Amazon themselves. So this is how you can work on EC2, IAM, and ACM and Route 53, using which you can create your own web servers. Let's proceed now. So let's go and refresh this once. Now you won't be seeing that warning icon over here because it has already been created for you. So this is the instances that we did inside AWS for the beginner part. Storage, we have already seen anyhow in the previous session. Next, let's go to our Glacier. Now, the concept of a glacier is that a glacier can be used to store any data for which you don't want to pay a huge amount. Consider the logs that are there for the last 7 days or last 7 years. Now, if the logs are for 7 years, you certainly don't want to keep them with you forever. Rather, you might want to go and remove them after some point of time, or let's say that you just want to go and put them into a storage medium that is not as expensive as your EBS or S3. So in this case, we will be creating something known as a Glacier, and a Glacier can store those logs or that particular data. For Glacier, I go and click on creating a vault. I give this vault a name. Let's call this vault as backup-vault. And if I click on next step over here, and if I want, I can also go and choose the notifications, because whenever you are adding the data in and out of your particular vault, it might involve time. So in that case, you might want to use a topic based on whenever this archival job was completed or the data is ready to be downloaded. So if you click on submit over here, now this vault has been created for you, which was created some time back. And if in case you want, you can go and expose your vault and you can save your data inside your Glacier vault. So this is it about the vault. So we were talking about the vault or the backup, how we can create it inside AWS. Let's proceed and talk about databases. So the database that we'll be talking about will be a NoSQL database and a SQL database. For the NoSQL database, we'll go in for DynamoDB. So If you have to work on DynamoDB, it works on the concept similar to your JSON object. So everything is in a object or a key pair fashion. So if in case you want to create a table, you just have to go and go to the tables, click on create table, and then you can create a table of your choice. So let's say I am creating a table by the name of student, and I am giving the primary key. Now, a primary key inside a table is the unique identifier for that particular record inside the table, which means that no other record inside that table can have the same primary key, or they can't have the same ID in our scenario. So if we click on create over here, we'll see that a table by the name of student has been created inside the database. Remember, this is a AWS or a Amazon managed database. So in this case, we don't have to worry about the performance because AWS is automatically going to handle the performance of that particular table for us. What we have to worry about is the capacity, or how many reads and writes you want to do per second. So in this case, if I am going for 5 reads and 5 writes, I am telling Amazon that if in case I need more, or I am using more than 70% of the capacity, AWS can automatically scale up the read and the write cycles for me, and the read at max will go up to 40,000 units. So this is about the databases for NoSQL database. Now, if in case I want to create a global table means that this same table that is present inside my region of Mumbai will also be created inside the next region, which can happen to be North Virginia, Ohio, California, Oregon, Cape Town, or any of the regions listed below. Now, when we say it can be inside any of the region, please remember that we will have to go and click on add region, and we can only choose the regions which are provided by AWS themselves. Now, next part is the backups over here. If in case you have a table and you want to create the backup of that table, you can just go click on create backup and give the backup a name. So I am saying something like, if the table name is student, I'll call it as student hyphen backup hyphen 04 July hyphen 2021. So this is how I am naming my backup. So if in case the data of my table is not available, or for whatever reason my table is actually deleted, in that case I can go and retrieve the content of my table using the backup, or even better, I can go and restore the data from that particular backup. So let's take an example of that. Let's say that by mistake, I have the student table and I delete the table. So let's go and type delete here. And let's say if I delete this EMP table also. So if I do this, if in case I want to go and take a backup, which I have done, I want to restore the content of my table, I just have to go click on backup over here. I see the backup created on July 4th. I will just have to click on restore backup, give the new table name, which I can say as student, click anywhere outside, click on restore table, and the backup of my DynamoDB has been created automatically by AWS. So this is another way by which you can go and export the data, or you can take a backup of your data if you so want. Now, if in case the backups are not required, we'll go and delete the backup. So let's go and delete that by clicking on delete backup and delete. Now, this backup, if you are trying to delete, it will actually error out. And the reason is this backup is actually being used at this moment to create a new table. So for that reason, you won't be seeing anything over here. But do remember that if in case the table has been created, you can very well go and delete that backup of the table also. Next, we go to our databases, primarily to the RDS database or to the SQL version of the database. Now, these databases are also managed by AWS themselves. You just have to think about the database, like which database do you actually want to migrate? Is it a MySQL instance or an Oracle instance, or whatever that instance type is? So for that, you can click on create a database here. And then you will have to choose the type of the database which you want to create. Inside RDS, we have 6 options: Aurora, MySQL, MariaDB, PostgreSQL, Microsoft SQL Server, and Postgres. So these are the 6 databases that I have inside AWS. AWS has also made it pretty easy for you by going for easy create option, and you can just choose what machine type you need, the production, dev test, or the free tier machine. If in case you go for any one of them, AWS is also telling you the price, that how much you will be charged per hour basis. Now, if in case you want to create a MySQL database, let's say, you can just go give the ID password, click on create database, and this RDS database will be created automatically for you. Now, if in case you have a database, it will show up something like this. In this, we have a database which is on a writer instance and a reader instance, which essentially means that this database is the primary or the master, whereas the second one is the reader or the secondary. Now, if in case, yeah, you want, you can also go and delete any of the instances if you want. So let's say I don't want to create my database or use it as of now, I can select them action and then choose delete, and you can go and delete the database if required. Now, you might be thinking that, is there a scenario in which I might want people not to delete my instances or my database cluster? Yes, that is also possible. For that, you will just have to go and create the IAM policies that we discussed earlier, and you can create a policy whereby everyone who is getting access to the database will not have the access to delete that particular database. So in some time, after both the databases are deleted, or my writer and the reader are deleted, my this particular database of RDS will also be deleted automatically. So let's go back. We have talked about our EC2. Let's go and talk about Lightsail also. So inside AWS, Lightsail is a easy way of creating the instances or the servers for you. Now, this can include the instances, it can include the containers, it can include the databases. Just a point to notice that Lightsail doesn't have multiple database options as compared to your RDS, where you had 6 options. Lightsail, on the other hand only has 2, which is MySQL and the PostgreSQL for version 9, 10, 11, and 12. So in this case, it's pretty easy because you just have to go give your login credentials, what it is, the password AWS can create, or you can create your own password. You can tell whether you need the high availability plan or the standard plan. Now, if you pay attention, the standard and high availability plan is that the price is exactly becoming double of it. So if you go for standard, you'll be paying $30, whereas for high availability, you'll be paying $60. The reason for that is that in case of high availability, I also go and create a additional database inside the availability zone. So essentially, now instead of one instance or one database, now you have 2 databases. So that's what explains high availability, because instead of one, now I have 2. Also, if the first database for whatever reason is not working or performing the way it should, my second database will automatically take over. So I can go choose my database and just click on create database, and my database will be created. If in case you want to go and create a storage, you can do that. For that, you will have to go and create your disk. Now, unlike your AWS EC2, where you had multiple options inside EBS, here you have these options: 8, 32, 64, this, and the custom pricing, in which you can go and put the size. The price of this will be $1.60 per month, which basically means it will charge you 10 cents for every GB. So whenever we talk about the pricing, there should be some template inside AWS which can easily tell me that what is the price of the storage. So that service is something known as a AWS calculator. We'll be using that to calculate the pricing, and we'll see which of this is better. Either EC2 is better or a light sail storage is better. So for that, what I'll do is I'll go and create a 1000 GB disk over here, and it tells me that the price is going to be $100 per month. Now let's go for our pricing calculator and we'll be calculating the same price over here also. So if I click on EC2 and I click on configure, next step will be to select the region. The region I'll be selecting it as Mumbai. And if I click on change region now, and let's say I just want the storage of 1000 GB. In this case, I have to pay $114, whereas in light sale, it was only costing me $100. But there's a catch, which is the GP2 is the older version. What I'll go is I'll go for the GP3 volume. So if I'm going for GP3 volume, which has 1000 GB, it has 125 Mbps throughput, and it has approximately 3000 IOPS, I'll be only paying $91 over here. Whereas inside my light sale, I was paying up $100. So doing the mathematics, we can understand that my EC2 EBS GP3 is cheaper by approximately 9% as compared to my light sale storage. Let's go back to our light sale. We have already seen the storage, we have seen the database, and now let's have a look at the snapshot. Snapshot is exactly the same as your snapshot inside your EC2. If you have an instance and you want to take a backup of that instance, or you have a volume and you want to take a backup of that, you can do that using your snapshots. Let's go to networking next, in which case, if in case you want to go for a static IP, a CDN network, a DNS, or a load balancer, this all four we have done prior, in which we created our website. So if in case you want to create that, you can go and do that also by clicking on the load balancer, let's say, and give the name of that and click on create load balancer. And over here, it will tell you the upfront price is $18 per month for using this particular service. Finally, let's go to the instances of light sail. If I click on create instance, I will have an option to choose any of these softwares. So these softwares are not the only thing present inside the instance. Rather, what AWS does is it gives you a template. Inside that template, you have the base operating system along with this particular software pre-installed. So from our perspective, we don't have to worry about installing that particular software. Rather, we can take a AMI, and that AMI itself is going to have this particular version of the program or software required. So if in case I need to create a WordPress website or a Joomla website or a engine server, main stack server, only Node.js, LAMP or PHP servers, cPanel for Linux. In this case, I can just click on this particular icon and I just have to go and click on create instance. AWS is also telling me that it will cost me approximately $3.5 a month, in which it will be giving me one virtual CPU, 512 MB of RAM, 20 GB SSD or storage, and the total transfer in and out which is possible is 512 GBs. So if in case I want, I can take this particular service of light sale. So this is about light sale. Let's go back and talk about the next service inside AWS, which is my Lambda. So if we have to go and work on a Lambda, remember that Lambda can be used for creating absolutely anything inside AWS. When I say anything, this primarily works on the API part, which means that I can go and create any resource inside AWS. So what we'll be doing is we'll be creating an example of Lambda. We'll be adding it with our CloudWatch, and we will be adding it with our SNS or simple notification service. So if in case something happens to my instance, AWS CloudWatch is automatically going to capture that event. It is going to send a notification to me on simple notification service, and eventually Lambda is going to take care of it. So next step that we'll be doing will be working on the SDK part of AWS, primarily on Lambda. So let's get started with Lambda now. So to work on Lambda, what we'll just take a use case scenario wherein, let's say that whenever my instance goes into stopped state, my Lambda should automatically trigger and start the process without any human intervention. So this is the program that we'll be writing inside Lambda, and we'll be using the services of AWS EC2, SNS, CloudWatch, AWS events, and Lambda for this. So first thing first, we should go and create a EC2 instance for ourselves so that we can ensure that we can perform any sort of testing on that particular instance. So let's go. And I see that I already have two instances, web server 1 and web server 2 over here. So pretty good for me at the moment. Now, next step will be to go and work on Lambda. However, before I get started with Lambda, because Lambda as a service has to go and use EC2 as a service. So in this case, I will have to go and create something known as a role. So what I will do is I will go and create a role which will be created for Lambda, which will be using the service of EC2. So let's go click on Lambda. Next, the permission. I will go and give it the permission for EC2, and I'll be giving it all the permissions for EC2. Next, tags and review. Here we will be giving it a name. So let's call the name as lambda hyphen EC2 hyphen all hyphen access. And let's go and give a description. Let's say Lambda can use all events for EC2 using this role. So once this is done, I'll just go click on create role, and my role is now up and running. So this role of Lambda can be used, and it can go and create or use any service of EC2. So for that, let's go back to our Lambda over here and start working on our program for that. So the use case will be that this Lambda program will ideally go and start my EC2 instance. So for that, we will go click on create function over here. And if you want to see the existing functions, by the way, you can just click on functions over here and it will show you all the functions which are there. Now, the thing is, because I already have multiple EC2 actions over here, what we'll do is, first of all, we go and delete all of them. And after that, we will go and create our new Lambda functions. So all the functions, they can be having the same code. That's not a problem. But the thing is, they cannot have the same name. The name is important because any ARN or Amazon resource name or the identifier of any particular resource in AWS is given via our ARN, and that ARN has to be unique. For Lambda, the ARN also includes the name of that function. So for that reason, you cannot have the function which is already existing in Lambda. Again, when I say not existing, it simply means that that particular Lambda function should not be by the same name. The code base can entirely be the same, that's fine. However, the name should not be repeated. So let's go and start to create a function, and this function I will name it as start hyphen EC2 hyphen instance. One important thing is I have to choose the runtime. I'll be choosing the default runtime, which is Node.js version 14. And then I will click on the role and choose the role that I created some time back for Lambda EC2 all access. So we'll choose that and we'll just go and click on create function, which will essentially go and create a empty function for me. Now, the important thing is that this function is an empty function. It doesn't have any code as it is, because we'll have to go and write the code ourselves. So let's get started with that. I will just go and maximize the window, click on index.js, and I will have to write the program over here. So let's do it in an easy way. I'll tell you a way by which I used to write the Lambda functions. You can choose the method yourself if in case you want to. So first thing first, what we'll do is we open our search engine. We'll go and search for the repo and alike. ANDLIKE. We click on the first one over here, and then we will open the repositories and we will open the Lambda repository. So let's go and search for Lambda, which is Lambda node over here. Next, if you scroll down, it will automatically tell you that you should ideally look for this program, which is sample program.js, which essentially is this, or you can directly click on this link. If you click on this link, just copy the complete thing and simply paste it over here. And that should pretty much be it. So in this way, the program skeleton template is there. Now our job is to go and write the program. So let's get started with that. Line number 1 says that I'll be requiring AWS SDK, and that's what it is. Line number 2 tells me to change the region. So my region right now is Mumbai, not North Virginia. So I will choose the region as AP-South-1. This line right now is of no use for me. We will use it in 5 minutes. Going back over here, I will have to give a function name. So let's go and give the name of this function as, let's say, start Ec2 instance. And the same thing I will name it over here. So this is just the function name. It's not doing any job as of now, and that's fine. We are going to do that in some time. So just understand the template over here. Let's remove this line so that it becomes easy for us to understand. I have the SDK part written. The next is the region, which is Mumbai AP South 1. Next, I will be writing the function. Finally, I am exporting it by the name of start EC2 instance. Next job will be to go and write the program to automatically start my EC2 instance. For that, I will go type AWS SDK and EC2. And it should automatically open the SDK or the software development kit for JavaScript. Let's just wait for this complete page to load up. Now that the page is loaded up, let's go and search for how to start an instance. So if I scroll down, I'm going to see start instances. So that's the one. We just have to simply go and copy paste this complete thing inside our Lambda function. So let's do that. And if I do this, I can remove the commented out code over here because that's not required for me at the moment. That is for you to understand that what the output is going to look like. So over here, if after if and else, so it's all good. Now the thing is that it says that EC2 is not defined, and it's telling you a warning symbol also over here. The reason for that is if you go on the top of the page, it's going to tell you that you will have to declare the variable for EC2 so that you can start working on EC2 as SDK. So for that, we'll just go down and place it like this. And if everything is good, this Lambda function should be good for me to go and start my instance, which is of this instance ID. Now we certainly know that our instance ID is not this. So we will go back to our EC2 and obtain our instance ID so that we can work on that instance. So let's go to instance running. And web server 1, let's take that example, and I take the instance ID over here and I just have to go and replace it as it is over here. Done. Now, because I actually want to see if it works or not, what I'm going to do is I'll just go and stop my web server 1. So this and stop. Now, if my Lambda function is working the way it has to, it means that if I go and start my Lambda function now, it should automatically go and start my instance, which is web server 1. That will be the proof for me that indeed my Lambda function is working. And once that is done, we will go and use this Lambda function inside our code, and we will create an event out of it. So for that, let's just start to work on that. So now that the instance is already into stopped state, let's just wait for the instance to go into stop. Now that is it is into stop state. We can go to Lambda and we can just go on test, give it a name. Let's say, let's call it as event 1, and click on test again. And if everything is good, this instance should automatically have started. Let's refresh it. And we see that the instance is still into stop state. So for that reason, we'll actually go back and have a look at why it didn't work. The reason for this is present over here on the top. It says changes not deployed. So whenever you are testing anything, you will first have to click on deploy over here. Once it becomes green, changes deployed. Now, if you click on test over here, it should actually give you the output of starting instance. And to test it out, we go to instances, we click on refresh page, and I see that indeed my instance automatically went into my running state. So a Lambda function can be utilized in this way, by which I can automatically use my Lambda function to start any of the instances. Next part over here will be to go to my Lambda function and my CloudWatch events. So if in case my CloudWatch events captures that anything or any of the service is not working the way it has to, in that case, it will automatically trigger an event which will eventually go and start the instance. So this can be done in two ways. We are going to see both of them. And during this, we are also going to understand the service of CloudWatch. So first of all, inside CloudWatch on the left, I'm going to see something known as a event. This event is also known as my events bridge. Now, so if I click on events on the left over here, I'll see get started. If I click there, and I can say my service is EC2, and it is for a specific case when my instance state changes. And whenever it goes into stopped state, and this particular instance, I'll just go and put the instance ID. If at all this instance ever goes into stopped state, in this case, what will happen is I will be triggering a Lambda function, and this Lambda function will be triggered. So this automatically is AWS is going to do it for you. I'll just go and put the name, let's say auto start EC2 hyphen instance, and the description I'll say in bracket, I will give the instance ID over here and create rule. Now, if this is done, this essentially means that if in case my instance ever goes down, a event will be triggered which will be instance stopped. And whenever my instance goes into stopped state, at that point of time, this particular event will occur which will trigger my Lambda function, which will eventually go and start my instance automatically. So let's go and try it out. For that, I'll just go and stop both of my instances, web server 1 and web server 2. Now remember, event was triggered for web server 1. So this one should be the one which is actually started in some time. Web server 2 will still be in the stopped state itself. So let's just wait over here. So now, as you have seen, my instance 2 is still into stop state. However, my instance 1 has automatically started. So this is what the Lambda function and primarily the events are doing for me. So let's do one thing. Let's go and terminate my web server 2. And once it is terminated, we'll again go and stop our web server 1, which will go and start my web server again via event. So let's just wait for it to be terminated. So as we can see, the instance is terminated over here. That's fine. Now what we'll do is we'll go and stop our web server 1, and we'll just wait for it, and we'll see that this instance goes into stopping state, then goes into stopped state, and the very moment it goes into stopped state, it automatically goes into running state again. This thing is also known as IaaC, or infrastructure as a code. In short, your Lambda or your code itself is managing the infrastructure of AWS for you. So if in case the instance is stopping, AWS is automatically going and starting the event. The services that we used over here are EC2, Lambda, CloudWatch, and CloudWatch events. Let's just wait for the instance to automatically resume. As you see, for it went into a stopping state, and then basically it is now into pending state, which means the instance has automatically started, and finally it goes into running state. So essentially there is no way by which this instance will remain into stopped state forever, because the moment it goes into stopped state, at that very moment this instance will again go into running state. So that's what we wanted to do using our Lambda function. So let's go and terminate this instance as of now. And we'll also go and remove our Lambda function. And eventually we will go and also remove the CloudWatch event that we created. So for removing that, select the event, click on action, click on either disable or delete. In my case, I'm choosing delete. And so we have deleted the event. Now let's go back to our Lambda, and we will also delete the Lambda function that we created inside AWS to manage the infrastructure. So for that, click on functions, select the function, click on actions and delete, and the Lambda function should be deleted. Now, if you remember on the top, it says that you have this much code space storage allocated for you, which is 75 GB. The Lambda functions are this many, that concurrency and the unreserved concurrency is set to 1000 and 1000. So if in case you ever want to know that what is the limit that has been set in AWS for you, the answer is you can click on your name, you can go to my service quotas and have a look at the limit which is allocated for you. Please remember that this limit is different based on your account usage and on factors which are so decided by AWS. So let's take example of EC2 that we have already done earlier. So if we click on EC2, let's go here. So if I ever want to know how many instances I can create for on-demand instances, my limit is 1280. However, by default, AWS has set the limit to 5. So if in case I want to go and create instances, I can do it within this limit, which is 1280. Finally, this range is inside Mumbai data center. So each of the data centers will have their own limit. Generally, it remains the same. However, there can be a difference based on the configuration of the data center and based on the limits as decided by AWS. So that was it about our Lambda. So right now we have seen certain services of compute, which were EC2 Light, say Lambda. We saw about storage, which was S3 Glacier. We saw about databases, which were RDS and DynamoDB. We have also seen about our Route 53. We have seen the services inside security for IAM, and we have seen inside management and governance, CloudWatch. And finally, if we have to notify, we have to use SNS, the service that we have seen. Now, for the next part, we will go and work mainly on the CLI part, and we will see that whatever jobs we did via our instances over here, the same thing can also be done via CLI. So let's get started with that. So the first thing to work on CLI is to create an instance. So this CLI can also be installed inside your servers like we have done already. So let's go and create a Ubuntu 20 instance, and I'll take a T3A small instance and launch and use the key pair that I have already and click on launch instance. Let's wait for the instance to come up. Let's call this as CLI-instance. If the instance is up and running now, let's go and work on that. For that, we will have to click on the connect button first of all, and I can use the browser-based access control itself. Click on the connect here. And I see that I have the connectivity with my instance up and running. So next step, like we did already earlier, was sudo apt-get an update. If you are using a distribution for Amazon Linux 2 or RHEL or CentOS, in that case, it will be yum update, sudo space yum space update. Once that is done, we'll go and install CLI. So for that, we go sudo apt-get install and AWS CLI. And just press Y, and AWS CLI will automatically be installed inside your instance. To confirm if CLI has indeed been installed inside your instance or not, we will go and wait for the installation to be done, after which we'll just go and type AWS inside our instance, and I should actually see it giving certain commands. So let's wait for that. Now, if I go and type AWS over here, I indeed see that this comes up. Now I'll have to go and configure my instance. For that, I'll have to go back inside my IAM user. Now that I have AWS installed, I can go and type AWS configure. So, okay, well, we did a spelling mistake. So let's go and type that AWS configure. At this point of time, it is going to ask me for the access key ID, secret access key, and the region. So let's go and get that. Similar to the last time, we'll go for our IAM, and we'll create a user which will have access to, let's say this time we'll give them access to IAM itself, EC2, and S3, and we'll try all the three services using CLI user. So let's go for users over here. We'll create a user. Let's put the name of the user as, let's say, CLI-user, a programmatic access. Next comes the permissions, wherein I'll be adding the permissions directly, which will be EC2 and S3. And let's say, let's give it a IAM access also. So IAM full access, tags, review, create user. Once this is done, I have my access key ID. I'll just copy it here and paste it inside my instance. This second part is to get the secret access key, which is this part here. And I go and paste it here. My region happens to be AP-South-1, and the output format is stable. Now, if I have to go and view the access. Let's try it out. Let's say I want to go and view all the buckets I have. So for that, the command is AWS S3 ls. If I do that, I'll get list of all the buckets. Let's say I want to delete a bucket. So let's just go and copy a bucket name here and give the command AWS S3 RB S3 colon / and the bucket name, and the bucket is indeed deleted. If I want to delete another one, let's try this one, AWS S3 RB S3 colon / and the bucket name, and indeed that bucket has also been deleted. Now in certain scenarios like in this one, this bucket is not deleted. So let's go and test it out, that why didn't it happen in the first place. For that, I'll go back to my AWS console. I'll go to S3 and I will have a look at my bucket first of all. So though AWS is telling you straight away, the reason for that is that the bucket is not empty as of now. Bucket not empty. So the bucket has some objects inside itself, and you cannot delete a bucket straight away which has some objects inside itself. So first of all, let's go and check it out. So let's go and do it like this. And I see the bucket. If I click on that bucket over here, I'll see that the bucket indeed has some items which are present inside that bucket. So what I'll do is I have two options. Either I can go and just do the AWS S3, in which case AWS S3 RB space S3 colon / the bucket name, and then I can put -- force. That's one way. Alternatively, I can delete it from here also. So what I'll do is for my sake, I'll go AWS S3 RB S3 colon or this and -- force. This basically is going to A, delete all the objects inside the bucket, and B, it's going to delete that bucket itself. So in this particular scenario, all the buckets that I have are deleted, and this particular bucket and all the objects inside the bucket are all deleted. So this is basically how you work on your CLI. So let's go and take another example. Let's say I want to stop my instance. So for that, I can do AWS EC2 stop -instances -instance ID, and I can give the instance ID. So let's go and get my instance ID from here. For that, let's go to EC2. And my instance ID is this here. Instance ID generally will always start from I - something. So let's go and get that. So for that, this part here, and let's go back to our instance and done. So if everything is done, my instance should automatically stop now. So let's have a look at that. If I go here and I just refresh my console, I'll see that the instance is now indeed into stopping state, which means if I go back to my instance and I try to make connectivity, nothing is going to work. And the reason for that is that in this case, my instance has gone into stop state. So this is how you can work on your CLI, on your Lambda and EC2 using AWS basic services. And this primarily is how the services of AWS also work. So before we wind up the session, we'll just go and take in two other services. The final one, the application integration services, which are simple notification service and simple queue services, also known as SNS and SQS. So let's go for that. But before we go there, let's just go on and terminate our instances. And what we'll do is we'll also go and remove the users that we have created. So for that, I click on instance state, click on terminate and terminate the instance. Finally, I go for IAM over here. And I will also go and delete the user that I have created earlier, because the SDKs are already visible for this user to everyone. So let's click on yes, delete, and indeed my user has been deleted. Now let's start with the final two services, which are my SNS and SQS. SQS basically is the simple queue service of AWS. This is how the queue actually works. So AWS has its own implementation of queue. So that is what this service is. In this, you can create multiple queues as and when you want. So SQS basically is a service or a fully managed service. By that, we mean that AWS manages it. We just configure the queue, AWS manages it and ensures that it is working the way it is expected to. So SQS is a fully managed messaging queue service that enables you to decouple and scale microservices, the distributed systems, and the serverless applications. SQS eliminates the complexity and overhead associated with managing and operating the message-oriented middleware, also known as MOM, and empower developers to focus on differentiating works. So using SQS, you can send, store, receive message between various components for any volume, and you can also ensure that you are not losing any message or require any other service to be available. You can get started with SQS in couple of minutes itself using the console or using the command line interface or the SDK of your choice. And this is pretty straightforward to create a queue. So in case of SQS, what we do is we create a queue. For that, you will just have to click on create queue on the top. You will have two options, a standard queue and a FIFO queue. Standard queue is a bit cheaper as compared to a FIFO queue. In case of a FIFO queue, the order is maintained. Let's say I have 10 messages, so they will be delivered in the order of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, which is not the case in standard. In this case, it will try to deliver the message. The ordering doesn't matter essentially. Next step is to give the queue a name. So let's call the queue as queue-home-Mumbai. Then if you go and create the key and click on create queue, this queue has been created for you and you can use this queue. So if you have to use it, you need the URL for that queue, which is available over here. So using this, if provided the permission or the access for that queue is given, you can create the queue over here. Now, if in case you need to delete the queue, you can just select the queue, click on delete, and the queue will be deleted. So let's go and have a look at how to delete the queues. Finally comes our SNS or simple notification service. This service is used by AWS to send notifications, which can be over email or Lambda or SQS, like the things that we have already seen. So in this case, what we do is we go and create something known as a topic, and the topic can have multiple subscribers. So let's go and create a topic. Let's say I'll call it as topic-email, and I will say this topic is for emails. And if you click on create topic over here, this topic has been created. Now you can create certain subscriptions. So let's choose the subscription as email, and let's just go and type in our email over here. If I do this and I click on create subscription, this email has been added to my particular subscription. The only thing required is that you will also have to go and confirm that you are indeed interested in this particular topic. So for that, what I'll do is I'll just open it here. So if I go open this, hit enter, it will say that you have subscribed, and this is the particular ID of that subscription. Going back to my topic, if I go, I'll see that an ID for that particular email subscription object has been created, which also means that if in case I publish a message like, let's say, class tomorrow, and let's put a message, hi at 10 p.m. If I add this and I click on publish message, in this case, this particular message will be published on my topic, which means this particular email ID would have also received this message. Please remember, these messages are sent by AWS using SNS. Thus, in case if you ever want to send any notification to yourself or based on certain scenarios, let's say my instance stopped or my instance terminated, or maybe my bucket had some operations. If any of this scenario you see and a notification has to be sent, you can take help of SNS. So that's it about the introduction to AWS. Let's just go and revise a few things very quickly. So AWS means Amazon Web Services. It's the cloud arm of Amazon, using which you can run your services without having your own infrastructure. Next part, on the top right, I see my region. I can choose any of the region, and if my account administrator has allowed, I can also go and work on that region. Over here, it shows me the account details. If you click over here, it will show you the account ID and also the name of that particular person who is owning the account. Here, if I have any ticket, I can go to the support center or to training or to documentation, and I can go and ask the question whatever I have. Finally, there are the services of AWS, and these services are primarily distributed into compute, storage, database, networking, management and governance, security, and application integration, though there are more services also which can be used. EC2 and EC2 and Lightsail can be used for creating your servers in real time. Lambda can be used to run the code without any basic runtime. You just have to go and write your code inside Lambda, and Lambda is going to ensure that that runtime is having that program. Then you have storage, which has S3, wherein you can store your data. You have Glacier for the archival data. Databases has multiple options. Primary of them is RDS, which is for your SQL data, in which you have options for 6 databases, followed by DynamoDB, which is your NoSQL data. Then we have our VPC, wherein we can go and create our network. We have option of CloudFront and Route 53, which we use to create our website, and this can be used for your DNS routings also. Then inside management and governance, which also we saw the service of CloudWatch, which can be used to monitor your resources. Inside security, identity, and compliance, we saw IAM, wherein we can go and create the policies or even add or remove a user or give them specific access. Finally, we went inside application integration, where we saw that we can use simple notification service to send emails and SQS if we have to work on the queues inside AWS. So this is what we saw inside AWS or Amazon Web Services, and this is the basic intro of AWS. I will see you in the next one.